Well, hello. Welcome to the IC Flores Software's new fire pump test program, an engineering tool to better evaluate risk. Before testing a fire pump, we should determine what type of pump are we testing. Is it a vertical fire pump or is it a horizontal fire pump? Is it a diesel engine driven or is it an electric motor driven? Are we testing the is this are we accepting the pump installation? Are we conducting a certain pump test? While we're doing a yearly capacity test. All these items should be determined before you even arrive at the site. Let's let's conduct let's simulate the test of an accepting a new fire pump, and we must accept it. In which case we need to compare the net curve to the shaft test curve. So we must have a shaft test curve available. If that's the case, we could click this button, NFPA or shaft curve, and we could enter data from the shaft test curve. We could compare the pump test to three curves: to the shaft test curve, which is the initial pump test, to the final acceptance pump test, which could be the secondary pump test, or to the NFPA, which would be the yearly capacity test. We're going to compare it to the shaft test curve. So we click shaft test curve. Next window open up, and we must have a shaft test curve in our hands. From the shaft test curve, we look at the graph and we pull out the pressure at churn when the pump is running without discharging water. And that pressure is 120 psi from the graph. At 100% capacity, the pressure is 100 psi. And at 150% capacity, the pressure is 70. So we're actually testing or witnessing the test on a 1000 GPM at 100 psi. So we click OK, and we're going to develop the shaft test curve, and below that we're going to develop a degradation line, a 5% degradation line for NFPA 25. You could also select 10% degradation line if you follow factory mutual engineering standard. We are following NFPA standards, so we click 5% degradation line. Our pump is a horizontal pump, so let's type horizontal. And we enter the pump rate from the nameplate. We enter 2000 GPM, which is the rated flow, at 100 psi rated pressure, at 1780 GPM. We could view a graph, and this is the graph of the pump of the shaft test curve, and this is a 5% degradation line. Now we're going to compare our pump test to this curve, to the shaft test curve, and we're going to determine if the pump test is excellent, good, or poor. If the net curve, which will be plotting also, falls above the shaft test curve, then the test result is excellent. If the net curve line falls between the shaft test curve and the 5% degradation line, the pump test is good. If the net curve falls below the 5% degradation line, the pump test is unsatisfactory. In which case, we must investigate what happened, fix the condition, and retest the pump. Let's go back. Now we could enter data by entering information right on the form. We could call this ABC coupling. And if you press the tab key on your keyboard, you go to the next open cell. So we are able to enter data in whichever the cursor is landing. Another way to enter that is clicking this form. And there's some advantage of clicking the form as opposed to entering data right in the sheet. And the data will be transferred to the sheet as we populate the form. Let's say, for example, We have ABC Company as a customer. We could change the customer name. We could put ExxonMobil, and there are 3X in Exxon, only 2X are permitted. ExxonMobil, and click next. The ABC company name was changed to ExxonMobil, and the next form 2, shows who is testing the pump and also what type of test is being conducted. We could say it's a yearly acceptance test, and after the pump test is tested, the person doing the test can look at the graphs and determine whether it's excellent, good, or poor. So that was done, and the excellent was selected, in which case excellent is typed over here. So by using the form, you avoid typing the word excellent and final acceptance test or yearly capacity test. The next, we click next, and the next form 3 opens. And this is for information regarding the person witnessing the test. Person witnessing the test could be the fire department. It could be a fire protection engineer from a property insurance carrier, in which case you identify purpose of witnessing the test, insurance review, management review, or fire department review. And the test, we call it, this is a fire protection engineer, so it's an insurance carrier. Company name could be ABC Company, FM, Factory Mutual. And according to them, the test was good. So there's some disagreement between the people doing the test and the people witnessing the test. They don't agree on the same performance. We click next. Now over here, we can start entering information about the pump. Horizontal pump, vertical pump, what size of pump. This is taken directly from the nameplate. I'm going to not enter this information. It will take too much time to enter, so I'm going to click cancel. And I'm going to bring a pump test that's recorded in the program for an actual pump test conducted. And we're going to click import sample test to populate the forms for demonstration purpose only. We're going to click import test data. And there are 2 pump tests that have been recorded that we're going to import. We're going to import an electric fire driven pump, electric fire pump, or a diesel fire pump. In which case it's a driven, electric motor driven and diesel engine driven. And the pumps are both the same size, 2000 GPM at 100 PSI. Let's bring the electric motor driven fire pump. We did that, and the form was populated. And the forms are basically sheets. This is Excel, and Excel basically has sheets, data sheets, or spreadsheet. This is basically a spreadsheet, although it looks and behaves a little bit different than a spreadsheet. It's actually a program on a spreadsheet. It's macro driven. It was written in Excel 203, but it works with all types of Excel. In this case, I converted Excel 203 to Excel 2016, and it works fine. We're going to look at the next sheet. The next sheet is the next button on the sheet tell you to go to the test header. We could test the pump using a test header, or we could test the pump using a flow meter. Per NFPA 25, you could test the pump using a flow meter for 2 years. On the 3rd year, you must discharge water, and you need to use a test header to record the test. So let's demonstrate the test header. We're going to go to the test header form. We're going to open it, and this is sheet 2. All the information is written here. It shows your actual speed, your discharge pressure, your suction pressure, and your net pressure. Net pressure is established by subtracting the suction pressure from the discharge pressure. And we'll plot a discharge curve, a suction curve, plus a net curve. We'll also be plotting a adjusted pressure curve. These are the amperage and readings. And you enter data, there are 4 points to this program. You could plot a 4.2 curve. The first point is churn, no flow information is entered. The second point, we try to plot a 50% of rated capacity. Discharging of water by using nozzles. In this case, we're flowing plate pipe nozzles. Point 3, we try to discharge 100% of rated capacity. We enter that information in this group of cells. And we try to flow 100%. On point 4, we could open more nozzles and we discharge up to 150% of rated capacity. Oh, a little bit less or a little bit more, but we must, when we plot the line, we must compare it against the Shapter's curve line that we previously generated. So this is the test data. Let's look at the graph. This is the graph that the program generated. It generated a discharge line, a net curve, an adjusted net curve. This is the Shapter's curve that we previously generated, and the 5% degradation line. This is an amperage curve, and this is a suction curve. Now, what can we determine from reading this? The net curve is above the Shapter's curve, so the results of the pump test are excellent. Had it fallen between the Shap and the 5% degradation, pump test will be good, but they are excellent. You know, the Shapter's curve is not near the 5% degradation line. So the test results are excellent. Now, look at the amperage line. Let's go back to test header. And let's see a statement that was generated by the program. It says some amp readings are higher than the maximum allowable amperage. Investigate this condition. My amperage reading, the highest amperage reading is 72 for 0.4. Let's go back to form 1 or sheet 1. In the sheet 1, we look at the driver. It is electric motor driven, G electric motor. The amperage is rated 60 amps from the nameplate information with 1060 amps, and we enter the service factor 1.15. If we multiply 1.15, the service factor times the rated amp times 60, we get a 69 maximum allowed amperage. Anything above 69, the program will generate a recommendation. So let's go back to test header. And we see the statement that was generated. If we change the amperage, any amperage that's above 69, we could delete. We delete the amperage at above 69, 70, 70, 70, 70, 72. And as soon as it erased the last number, the statement on amperage is gone. If we again come back and put 70 in any area, the statement comes back. So this helps you make recommendations on amperage if the amperage goes above the expected level. Now, how do we enter data? We go enter data into the unprotected cells, and wherever the cursor lands is unprotected, so go enter data. As you can notice, the cursor did not land in the nozzle and coefficient or K factor table. or pitot pressure. In there, we cannot enter data. These cells are protected. Although we could highlight it, we could not enter data. If we try to change a number, we get this statement. It's protected, so we cannot change that. To enter data in this area, we need to click the red buttons. We click it, and this window opens up to allow us to enter data. Although it's much easier than typing the information. We go into data from plate pipe nozzles. We go into data from fire hydrants. Sometimes we don't have a good means to test the pump, and if the pump is supplying fire hydrants, we go open fire hydrants and test the pump that way. But that is rare. It's better to use either plate pipe nozzle or hose monsters. Pitotless nozzle. The next item is pitotless nozzles. And pitotless nozzle can be discharged like to open atmosphere, or you could attach a hose monster. Well, a big boy hose monster or a little hose monster. But these are pitotless nozzles. And there are about 9 that you could choose from. Next item is hose monster. You could choose. Hose monsters are bigger. They go up to 4.5-inch diameter, and you could select from 1 1/8 to a 4.5-inch. And this is a hose monster. This is what it looks like. So you could attach a pitotless monster to a hose, and then to a pitotless nozzle that's inserted inside the hose monster. You could test using big boy hose monsters. Another way to test is using pitotless nozzles, inline pitotless nozzles. This is mainly used to test sprinkler systems like 2-inch drain tests and smaller flow. Not so much for fire pump, but sometimes if you're testing in a city like New York City, there's no place to discharge water, we might be forced to test using inline pitotless nozzles. Click next. The next item is other type of nozzle or streams. And we could discharge from a pipe. The pipe could be any diameter. If you know the coefficient or the K factor of the pipe and the diameter, then you could discharge that way. And we could demo this. Let's discharge using a pitotless nozzle. We could discharge a 2-inch pitotless nozzle plus a little hose monster. So we click that. When we do that, the window's open, so we can enter the quantity of nozzle. Let's say we have 2 of those nozzles. And when we click OK, the next window opens up to ask us the pressure. So we got a pressure of 22 psi from each pitotless nozzle. We click next, and we click next. The program enter the numbers of nozzle, identify the size and the type of nozzle. It entered the coefficient, the K factor of the nozzle, enter the pressure, and calculated the flow of each device. We could enter other devices. Could click a fire hydrant, and this is going to be from 2.5-inch fire hydrant. We identify the coefficient by open the bottom of the hydrant and putting your finger inside and feeling how the hydrant opening is inside. Is it round? Then the coefficient we use is 0.90. If it's a square sharp like this, the coefficient will be 0.80. And if the nozzle protrudes inside the hydrant, then the coefficient is 0.70. If you have a stream straightener attached to the fire hydrant, they will use a coefficient of 0.95. So let's use a coefficient of 0.90. We identify the numbers of nozzle. In this case, we got 2. And we enter the pressure of each nozzle. Let's say it's 24. We click next, and we click next. So this is what we just entered. Again, the flow is calculated, And as we enter information, the flow changes by percentage. The flow went from 100% to 256%. And if you want to view a graph, the flow exceeded the pump 3000 GPM, and it went to 5000 GPM, a little bit over 5000. And this only applied to 3 points, 1, 2, 1, 2, and 3. Point 4 is not yet put in. So we go back. Well, point 4 is only 3000, 151, 3000 GPM. Anyway, to delete information in the data, you click you identify, you go to the row that you want to delete. In this case, you want to delete this information. If we try to delete it, click delete, it's protected, so it will not erase. So you click the button, the red button, click OK on the little window that opens, and then you go to erase row and click that button. That button will erase the row that was selected. Let's erase this row now. Erase, click OK. So now if you look at the graph is normal, except for the amperage. The amperage really looks weird because we changed it. So let's go back. And I'm just going to bring the imported test data that was previously imported. We go to the test header form, and we are back with all the amperage readings. We look at the graph, and the graph is good. Now, if you are if you're from representing the pump company doing a final acceptance test, then you're done with the test. You just gotta submit the report to your customer. As a fire protection engineer representing a property insurance carrier, we need more information. We consider the pump test performs excellent, and that's good, but the fire pump provides water to the sprinkler system for fire protection, for automatic fire protection. We need to know that not only that the pump performs excellent, but can it meet sprinkler demand? So we could enter sprinkler demand and compare to see if the pump performance met sprinkler demand. We could click go back to test header, and we could select sprinkler demand. Click the button, little windows open, and now we have information to open sprinkler demand. Now, some facilities have small, they only have one sprinkler system, and some facilities are very large, chemical plants with 100 or 150 sprinkler systems. If you have multiple sprinkler systems, I would enter the largest sprinkler system. You could enter, and instead of entering every large sprinkler system, you enter the sprinkler system with the largest pressure, the sprinkler system with the largest flow. So the sprinkler system with the largest pressure is rated it's 1000 GPM, about 145 PSI for this facility. And the sprinkler system with the largest flow is 2500 GPM at 95 PSI. We're gonna give fire department some water for hose protection and based on occupancy. This is a high hazard occupancy, and the hose demand is 500 GPM that we must reserve for the fire department. We click next, and now we can view the graph. So the graph changed. We had the discharge line, but now we got a hose line beneath it. This hose line is represent 500 gallons per minute subtracted from the discharge line. Then we have two sprinkler systems, sprinkler system 1, sprinkler system 2. This sprinkler system, it represents 1,000 GPM at 145 PSI. And this sprinkler system represents 2,500 GPM at 95 PSI. In this facility, the pump not only performed excellent, but it meets sprinkler system. It meets the largest sprinkler demands with hose protection and a little safety margin. So protection in this facility is good. We click OK. So this facility is a good risk. We evaluated the risk by testing the pump. We can evaluate the risk that the insurance company is insuring is a good risk for the insurance carrier because it has adequate protection. This is based on protection. You got to look at all the features: construction, occupancy, process. But based on fire protection, the risk looks good. Click OK. We'll go back to the test header. Now we must generate a report to give it to the property owner. There are two reports that can be generated, and we show both. We click Generate Report 1. And let's scroll up. Based upon the date of the report, June 2018, the program labels the report. This is the 2018 fire pump test report. It shows customer information, fire pump testing company, people witnessing the pump test, fire pump nameplate data, right angle gear nameplate data, which we don't have, that's only for vertical pumps, driver nameplate data, controller nameplate data, jockey pump nameplate data, and the fire pump test header data. If you keep scrolling, it shows the graph. So the report was generated by taking 3 sheets and putting it together. Easy. And it's done automatically for you. And each line is labeled. If you click Print Report, this is what a printed report will look like. It shows page 106. We click Next. That's page 206. Page 306. Page 406. Page 506. And page 606. We close this. And we could print the report and send it to the customer. There's also a brief report. Let's go to go to report 2. Report 2 looks like the entry data form. And if you print it or click print, this is the page 1 will looks like the test data that was entered. Next page, it looks like the test data. And page 3, next page is the graph. Let's go back. And if you look at the test data, there's blank rows on the test data. We could filter the test data. If you click filter, you will see that the blank rows have been eliminated. If you click print, you go to the next sheet. This is the test data, no empty rows. We close. We can filter the data. Now let's go back. Let's go back to report to report 1. In addition to printing the report, we could also generate a PDF file, which you could electronically send to the company. Let's demonstrate that. We could click Save as PDF, click it, and this works on the newer version of Excel. If you choose to have the program in Excel 203, it will not generate a PDF. Excel 203 will not generate a PDF file. But I think newer version, Excel 2010, 2013, 2016, 2019 will do generate. This is the PDF report that's generated. If you scroll down, you see each page, page 1, page 2, page 3, 5. You got to scroll slowly, otherwise you miss a page. Anyway, you could click Save this file as a PDF and email it to the customer. I'm going to go back to Excel, to the Fire Pump Test program. We'll click Go Back and go back to the program. This demonstrates the main features of the Fire Pump Test program. If you have questions about this program, you could go back and view about this program. And my email is isaacflores@gmail.com or isaacflores@gmail.com. Send me an email message. Let me know what you want to do. I have some people have viewed the previous Fire Pump Test program, which is also a very good program, and they emailed me to buy the program. I sold the program to those people viewing the program in YouTube. Any questions, give me a call. I'd love to hear from you. Thank you for viewing the Fire Pump Test program. Bye.